Okay, let's do a problem from chapter 19. The fission fragment iodine 131 undergoes negative beta decay. Complete the reaction equation and identify the daughter nucleus. Okay, so this will be our daughter nucleus right here. On these problems, what you got to do is say, okay, I started with so many protons and neutrons. That's what that number represents. And then I have so many protons down here. That's what that number represents. Okay, so we're going to make sure the tops on the left is equal to the tops on the right, and the bottom on the left is going to be equal to the bottoms on the right. Okay, we can create energy and whatnot, but we're going, the neutrons and protons all are going to add up here. Okay, so that's how I say. Okay, that's how I say to do it. Make sure the tops are equal on both sides and the bottoms. So looking at the tops, we have 131 on the left. Then we have this 0. So I'm going to put an equal sign. 131 equals our x. So this has some number up here. Plus 0 plus 0. So whatever daughter nucleus this is, it has a mass number of 131. So we know that this number right there is 131. Okay. So now let's do the bottoms. Change color here. Let's go to purple. So 53 on the left is equal to, all right, we got x. We don't know what this is on this daughter nucleus. We know that we have a -1 here, and on this antineutrino it's 0. So this guy really doesn't count for anything. Okay, so 53 is equal to x plus a -1. So we must have created, this must have one more proton than this iodine. So we have 54 is equal to x there, and this x, the blue x, was 131. Okay, so this is 54. And you're like, okay, well, I know what the number of protons are, I know what the number of neutrons are, so how do I find out what element this is? Well, you're going to have to do what I do, and you're going to have to look at the periodic table. So let me look up periodic table real quick. And we need to go by, okay, someone's calling me. I'm going to decline that for right now. Iodine, 53, so we're at xenon. So go by, these are atomic numbers up top here. I don't know how well you can see that, I'll zoom in. So iodine's at 53, that is its atomic number. Add one more proton, because that's what we wanted to do, right? Yeah, we have 54 protons now. So we're at xenon. So we have the xenon, which has 54 protons, and its mass number, its number of protons and neutrons is 131. And that's your answer. Let's do one more. Hopefully I won't get a face chat while we're doing this, or a FaceTime. Suppose that we have 10,000 atoms of a radioactive substance with a half-life of 30 minutes. How many atoms of that element remain after 2 hours? How many atoms remain after 4 hours? Okay, so I'm going to draw a picture to do this problem. We got some atoms here. We have 10,000 atoms. Okay, that's my 10,000 atoms. We're going to go 30 minutes. We're going to look at this in 30-minute intervals and see what happens. So in 30 minutes, a half-life means half of this will be gone. So if we have 10,000 here, in 30 more minutes we're going to take 10,000 and divide by 2. And we get 5,000 atoms, right? Alright, so just a little less. Now we're going to go 30 more minutes. Okay, and we're going to divide by 2. Divide by 2. We're going to divide this number by 2, the 5,000. We have half of that number. I'll draw some more dots. And we have 2,500. We're going to go another 30 minutes. And we're going to have half of that. So we're going to take our number, divide by 2. And we have 1250. Now we're going to go 30 more minutes, because that's a complete 2 hours, right? And we're going to divide by 2. Oh, I just had it. Why did I do that? Okay, 1250 divided by 2. 625 atoms. Alright, so that's how you do A. B, you'd do the same. You'd just keep, so you have 4 more 30-minute intervals, so take 625 and just look at what would happen to it in 30 minutes. So divide by 2, divide by 2 again, and then you divide by 2 again, and then divide by 2 again. And that would be how many atoms you'd have left over. Okay, go ahead and keep it in a fraction if it ends up being a fraction. Right, I'll let you do the math. Take 625, divide by half, divide by half, divide by half, divide by half, and that's your answer.